Okay, so today we're going to be looking at how we can find the area of a segment of a circle. So when we're talking about segments of a circle, we're talking about the part of the circle right over here that's shaded, like at the end. What's interesting about these is that it's not really a full half of a circle. It could either be like this sort of chunk, or it could either be like this tiny little chunk, like as colored in green. This is also a segment of a circle. And to do that, we just need to find two areas. We need to find the area of a sector, which we learned yesterday, and the area of a triangle. So if we look here on the circle that I drew with the green segment, you have your sector, but you have this triangle that is like separating the center point from the segment. This triangle, we're going to use our area formula of a triangle, which is A is equal to 1/2 base times height. That's what we're going to be using to find that area of a triangle. And it's important to note that the triangle over here, they're always equilateral triangles. What we mean by equilateral triangles, that's a triangle with equal sides. Okay. All right. So, and again, like if you need to pause the video at any time, you can just take notes. Okay. So first, we're going to start off what we did yesterday, finding the area of a sector. So yesterday we had this formula, and we're just going to substitute it. So the measure of AB. So from just like what we did learn last week, if this central angle is 60, then the outside arc that it's facing, it should also be 60 degrees. So over here, we're going to write 60 over 360 times pi. Now our radius is 18 squared, all right? Now 60 and 36. All right, so with this one, we need to simplify that. So we're going to be using this calculator that disappeared behind the screen. Okay, so now let's say, for example, I'm trying to find the greatest common factor between 60 and 360, right? So we could think about the multiples, but if you have a scientific calculator, a graphing calculator like this, you can actually press math. And if you scroll down, if you go to the side where it says num, and you go all the way down to GCD, you can actually use that to find a greatest common factor. So I can just put in 60 and 360. No, that's not what I want to put in. 60, comma, 360, close parentheses. Your greatest common factor is 60. So if I were to simplify 60 divided by 360, the fraction, I'm going to divide 60 on both sides. I'm going to wind up with 1 over 6. So this one right over here, this would be 1/6 times pi times, now let's see, 18 squared. So this one, it's going to be 18 to the second power. This will be 324. Okay, so we can go ahead and multiply that. We just want to multiply all these things together. So if we bring this up again, we have let me just put this in parentheses, 1 divided by 6, close parentheses, times second pi times 324, you're going to get this answer. Now, with this over here, you want to take it to the nearest hundredths place. So I'm going to round it to 169.65. Okay, so let's write that down. 169.65. And now we have to move on to the area of the triangle. Now with this triangle, they gave us the angle, it's 60. But if we remember from the area of a triangle, we need the base. So we need this dotted line that cuts through the 60. So first we want to cut the 60 in half. Half of 60 is 30. So this angle right over here, this will be 30. Now we're trying to find our height, the height of this triangle. So what we can use over here is our trigonometry. So if we notice from this angle, we have the hypotenuse, and this dotted line, the height, it's adjacent to it. So I'm going to use cosine. Cosine is 30 adjacent, that's what we're looking for, over hypotenuse. Okay, and now I could just go ahead and cross multiply. So I have x is equal to 18 cosine 30. And remember, when you're putting this in your calculator, you want to make sure your mode is in degree. So let's just check our mode. And yes, it's in degree right over here. So if we're gonna enter 18 cos 30. You're gonna get 15.59. So let's write that. Now this isn't our final answer. That is just that's just the height. That's just the height that we need so that we can put it into our area formula to find the area of a triangle. So now I'm going to take this, no, not that one, this, and then I'm going to put it into my area formula. So area is equal to 1/2 base times height. Half, the base is going to be 18. The height is 15.59. And then with the calculator again, you're going to go ahead and multiply that. So 1/2 is the same as 0.5 times 18 times 15.59. And that's going to be 140.31. 140.31. Okay, so now I'm almost at my answer. I have the area of the sector. I have the area of the triangle. Now all I need to do is find the area of the segment. And to do that, I'm just going to subtract the two. I'm going to subtract the sector area, which is 169.65, minus 140.31. And when I subtract the both of them, so 169.65 minus 140.31, I'm going to get 29.31, 29.34. So let's write that down. 29.34 inches squared. And that is going to be the final answer right over here. So that So that was how we are finding the area of a segment. There is a lot of parts to it, but for this worksheet, remember, we're focusing on at least attempting and practicing the techniques that you see in the video. The main idea is going to be the same. You're taking the area of a sector and you're subtracting that from the area of a triangle to find the area of a segment. This is a hint for your attendance question. So when they ask you, how do you find the area of a segment? You can just say, well, you got to subtract the area of a sector. Sorry, you have to subtract the area of a triangle from the area of a sector, and then you'll get the area of a segment.